Hey everybody, and owners pre-calculus. Welcome to lesson 7.2, arithmetic sequences and partial sums. So the next two lessons are going to be about two different types of sequences. There's arithmetic and there's geometric. And arithmetic means that there's a common sum or difference, well, a common difference between each of the terms that's either added or subtracted. And then a geometric sequence is when there's some number, like a ratio that's being multiplied by every term to get from one to the next in a sequence. And so today's essential question is, what are the properties of arithmetic sequences and their partial sums? So we're going to be talking about like sequences of numbers where there's a common difference, and what happens if we try to add those sequences terms together. Here's what we're going to do. Students will understand that in an arithmetic sequence, the difference between any two consecutive terms is always the same number. And students will understand that in an arithmetic sequence can be defined explicitly by describing its nth term with a formula using n, or recursively by stating its first terms and a formula for its nth term. And you should already know the idea of a sequence, which is just a series of terms, and a series, which is when we add those terms together. And obviously, you know what a sum or a difference is. And today we're going to be talking about common difference. And here's an example of a question you'll be able to answer easily after this lesson. Determine the seating capacity of an auditorium with 30 rows of seats if there are 20 seats in the first row, 24 seats in the second row, 28 seats in the third row, and so on. You could probably answer that question right now if you had a couple minutes to kind of like figure out how many seats were in every row and then add them all together. But we're going to go through a nice, simple formula where you'll be able to figure that out pretty quickly by the end of this lesson. All right, so let's head over to the notes. All right, let's get started. 7.2, arithmetic sequences and partial sums. The first definition we're going to go over is arithmetic sequence. So just to let you know, this word in this form is pronounced arithmetic. It's not arithmetic. So this is an arithmetic sequence. A sequence is arithmetic if the differences between consecutive terms are the same. So the sequence a sub 1, a sub 2, a sub 3, etc. is arithmetic if there is a number d such that a2 minus a1 is equal to a sub 3 minus a sub 2, etc. And that all of those subtractions equal d. The number d is the common difference of the arithmetic sequence. The nth term of an arithmetic sequence has the form a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference between consecutive terms of the sequence and a sub 1 is the first term of the sequence. We'll also be looking at the sum of a finite arithmetic sequence, but we'll get there when we get there. Let's start out looking at example 1, just kind of exploring some arithmetic sequences. We're going to start by writing the first four terms of each of these. So first is the sequence whose nth term is 4n plus 3. For this sequence, the common difference between consecutive terms is 4. So to figure out the first term, we're going to plug 1 in for n. And when we do that, we get 4 times 1 plus 3, which is going to be 7. To figure out the second term, we plug 2 in for n. We do 4 times 2, which is 8, plus 3, which is going to be 11. And then we plug in 3 in for n. We're going to get 12 plus 3, which is 15. And now you should be able to see that since this common difference is 4, we did 7 plus 4 is 11, plus 4 is 15. So if we add 4 again, we're going to get 19. And there's the first four terms. So whatever this number is that's multiplied by n is also going to be the common difference, because whenever we increase n by 1, we're going to be adding this number again, right? Let's try letter B. The sequence whose nth term is 7 minus 5n. For this sequence, the common difference between consecutive terms is negative 5. So this time, we're going to plug in 1 for n. We get 7 minus 5. So we're going to start with a 2. For the second term, we plug 2 in for n. We do 7 minus 10. We get negative 3. 7 minus 5 times 3 is going to be 7 minus 15, which is negative 8. And now you can see that indeed this common difference is -5. We're subtracting 5 every time. So the next term is going to be -13 and so on. All right. That brings us to letter C. This time we have the nth term of 1/4 times the quantity n plus 3. So it's going to be easiest, I think, this time if we distribute this 1/4. It becomes 1/4 n plus 3/4. So we'll start out by plugging in 1 for n. We have 1/4 plus 3/4, which is 1. Then we plug in 2 for n. So we have 2/4 plus 3/4, which is going to be 5/4. Then we plug in 3. 3/4 plus 3/4 is going to be 6/4, which reduces to 3/2. Then we plug in 4. We get 1 plus 3/4, which is 7/4, and so on. The common difference is 1/4, so you can see every time I added a fourth. 1 plus a fourth is 5/4, plus a fourth, plus a fourth, and so on. That's what's going on there. All right. So there's some, examples of arithmetic sequences. And that brings us to example 2. Finding the nth term of an arithmetic sequence. For a formula, find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Well, the formula for the nth term of an arithmetic sequence is at the top of the page, and it's a sub n equals a sub 1 plus n minus 1 times d. Right? And so the question tells us that the first term is 2, and the common difference is 3. So that's d, and that's a sub n, rather a sub 1. And so if I fill in the rest of this formula, I shouldn't have something to plug in for n because n is going to change depending on which term we're looking for. So just to make this a little bit nicer, I'm going to distribute the 3. Simplify, we get 3n. 2 minus 3 is going to be minus 1. So we have 3n minus 1. All right. Great. Let's move on to example 3. Writing the terms of an arithmetic sequence. The fourth term of an arithmetic sequence is 20, and the 13th term is 65, right? The first 11 terms of this sequence. So what we could list right now is that a sub 4 is 20, and then there's a bunch of terms in between that and a sub 13, which is 65. So we should be adding something several times to get from 20 to 65. So here's what I think through to answer this question. I'm going to say a sub 4 and a sub 13 are 9 terms apart. Right? If I add 1 over and over to get from 4 to 13, I'd have to do it 9 times. In other words, 4 plus 9 is 13. So let's figure out the current difference between 65 and 20. So 65 minus 20 is 45. And something was added 9 times to get a total of 45. So if I divide that by 9, I'm going to get 5, which means our common difference must be 5. So the question says, right, the first 11 terms of this sequence, we already have the fourth term. So I'm going to start by just listing that fourth term is 20. And I need to get the third term, the second term, and the first term. So I'm going to subtract that common difference 3 times. So we're going to get 15, 10, and 5. And then I need to get up to 11 terms. So if that's a sub 4, I'm going to do this a few more times. So you're going to need 25, 30, 35, 40, 45, 50, 55. That should be 11 terms, 5, 6, 7, 8, 9, 10, 11. Yep, and so on. So just counting by 5s, pretty simple once we see it, but that is how we go about a question that's phrased like that. So let's just box in our answer. There we go. All right, example 4, using a recursion formula. Find the 9th term of the arithmetic sequence that begins with the first term 2 and the second term 9. So recursion means that the consecutive terms are defined by the terms that come before them, or like the Fibonacci sequence that we looked at. So in this question, we're given the first two terms, and we're not given the common difference. But with an arithmetic sequence, the common difference isn't that hard to figure out, right? If we have two, especially if we have two terms in a row, I can just do 9 minus 2, and now I know that the common difference is 7. So if I wanted to find the formula for a sub n, just like we did 2 examples ago, we can, right? Because we know the formula is a sub 1 plus n minus 1 times d. So I know the first term is 2, and the common difference is 7. So let's just make this look a little prettier. 2 plus 7n minus 7, we get 7n minus 5. And now if I wanted to find the 9th term, I'm going to find a sub 9 by plugging in 9 for n. So we do 7 times 9 minus 5, which is going to give us a 9th term of 58. Example 5, finding the sum of a finite arithmetic sequence. So this is going to take us to the third formula from the front of the notes. The sum of a finite arithmetic sequence with n terms is s sub n. Capital S is a common variable that we use for sum. So a sum of n terms is n over 2 times, in parentheses, a sub 1 plus a sub n. Notice also that the name of this section of notes is called arithmetic sequences and partial sums. This ... here means that technically an arithmetic sequence could go on forever. So when we limit the number of terms that we're adding together, we're not adding together infinite terms of a sequence, but we're adding together a finite arithmetic sequence. We call that a partial sum. So it's a partial sum of an infinite sum. That would be if this was an infinite sequence. So that's what's going on there. That's why it's called a partial sum. But yeah, let's apply this formula in the next example. Find the sum. All right, so the formula is capital S sub n equals n over 2 times a sub 1 plus a sub n. So we got to figure out how many terms are we actually adding together here. Now, this isn't that hard of a sequence, right? I could probably take about 10 seconds to type that into a calculator and we would have the answer already. But that's not the point. The point is that we get used to using this formula so we can apply it in a more complex situation, like the next question, find the sum of the integers from 1 to 100. That would take a little bit longer to type into the calculator. So let's try this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that we're adding together here. So n is 10. And a sub 1 means what's the first term in the sequence, which we can see as 1. A sub n means what's the 10th term, or the last term. And that's a 19 in this case. So we're going to have 10 divided by 2, which is 5, and 1 plus 9, which is 10. Why am I writing a 9? That should have been a 19. So a sub n was 19. My bad, my bad. And 1 plus 19 we know is 20. So 5 times 20 is 100. So without actually using the calculator to type all of this in, I figured out that the sum of all the numbers is 100. So let's try example 6, finding the sum of a finite arithmetic sequence. Find the sum of the integers from 1 to 100. All right, so that's 100 numbers. So we're going to do 100 over 2. Remember, integers just mean like all the whole numbers from 1 to 100. The first term is going to be 1. The last term is going to be 100. So all we have to do is calculate this, and that'll be the sum of all the numbers. So we do 100 divided by 2 is 50. 1 plus 100 is 101. You multiply 50 times 101, and we get 5,050. And that is the sum. All right, that's it. Letter B, find the sum of the integers from 1 to n. So this is going to give us just a general version of the formula. So we're going to be doing the sum of capital N terms. There are capital N terms over 2. The first term is 1, and the last term is N. And that's really all we know. We don't know what N is, so that's going to be our answer. So that's more of like a theoretical application there. All right, let's keep going. A couple more questions to get through. Example 7. Find a partial sum of an arithmetic sequence. Find the 150th partial sum of the arithmetic sequence that starts with 5, 16, 27, 38, 49. So the first thing that I'm going to do is try to just learn a little bit more about this sequence, because think about the formula that we're going to be doing. We're going to be doing S150. And so I know N is 150. I need A sub 1 plus A sub N. A sub 1 is going to be that first term. I know that that's a 5. A sub N is going to be the 150th term, right? So I need to know what the 150th term is in this sequence, and I don't know that right now. But that's going to be the easiest way to find the sum, as opposed to trying to calculate all of the 150 terms here and then adding them all together. So what I need to do is figure out what is the common difference, what is the formula for the nth term. So let's try that. So A sub N is the first term plus N minus 1 times the common difference. That's what comes next in this formula. So I need to know, what am I adding to get from 5 to 16, to get from 16 to 27, to get from 27 to 38? Is it consistent? Well, it tells us it's an arithmetic sequence, so it better be consistent. And it is. It's 11, right? You can tell we're adding 11 between every term. So I'm going to be multiplying N minus 1 times 11. I'm going to kind of simplify this. And we end up with 11N minus 6. So I need the 150th term. So I'm going to plug that in for N. We get 1,644. So that means that's what I'm plugging in down here in this formula for the 150th term, 1,644. And lucky for us, I don't have to calculate all of the other terms in between. I just needed the first term and the last term. So now I'm going to actually solve this. So it's going to be 75 times 1,649. We end up with 123,675. And I'm really glad I didn't have to do that by hand. Okay, let's keep going. Example 8, prize money. In a golf tournament, the 16 golfers with the lowest scores win cash prizes. First place receives a cash prize of $1,000. Second place receives $950. Third place receives $900, and so on. What is the total amount of prize money? Well, let's try to approach this in a similar way that we approached the previous question. So we need to first start by finding the formula for the nth term in the sequence. And the reason we need this is because 16 golfers are getting prizes. In order to do the sum formula, we need the first and the last term. And I don't know the 16th place score or prize total yet. So I need to figure that out. So the first term is going to be 1,000. And I need the common difference. So what's the difference between 1,000 and 950? Between 950 and 900, it's going to be negative 50. So let's simplify this formula. We've got 1,000 minus 50n plus 50. So 1,050 minus 50n. And I know when I've been doing this, I sometimes switch which order where I put the n term and where I put the constant term. I usually just say if one of them is subtraction, I usually put that one second, but it really doesn't matter. I could have had negative 50n plus 1,050 and it would have been the same thing. But I need the 16th term because that's the last person that gets a cash prize. So I'm going to do A sub 16. It'll be 1,050 minus 50 times 16. And that's going to be 250 as the lowest prize. So the sum of the first 16 terms in this sequence is going to be 16 over 2 times the first number plus the last number. So we get 8 times 1250, which is $10,000. And that's how you do it. All right, one more similar question. Example 9, total sales. Small business sells $10,000 worth of skincare products during its first year. The owner of the business has set a goal of increasing annual sales by $7,500 each year for 9 years. Assuming that this goal is met, find the total sales during the first 10 years this business is in operation. All right. Well, we are already told the common difference here, right? It says in the second sentence, the goal is increasing annual sales by $7,500 each year. So it's going to be adding $7,500 to the total every year. Okay, so we're not just trying to find the amount of money that this business sells during the 10th year, right? We're trying to find the total sales during all 10 years. So it's going to be taking the amount of money that we get each year and then adding all of those together. So we do need to use a sequence for this. So let's figure out the nth term. We're starting with 10,000 and we're going to add 7,500 every time. So if we would simplify this formula, it's going to be 10,000 plus 7,500n minus 7,500, which will be 7,500n plus 2,500. So the 10th term is going to be 7,500 times 10 plus 2,500, which is 77,500. And then we need to find the sum of the first 10 terms. So it's going to be 10 over 2 times the first term, which is 10,000, plus the last term, which is 77,500. That's crazy. That business got a lot more successful in those 10 years. So let's see what we got. We got 5 times 87,500, which is going to be a total amount of money in sales over the course of 10 years of $437,500. Pretty crazy. All right. And that is the last question in the notes. So hopefully that makes sense. We're covering arithmetic sequences and their sums. Please let me know if you have any questions, and good luck with the worksheet and have a great day. Thank you very much for watching.